Goddess of Science Physics, and today we're going to do some weight on different planet exemplars. So you already know how to use the weight formula, Fg, force due to gravity equals mass times the acceleration due to gravity. So now I'm going to teach you how to do that when it's something other than the acceleration due to gravity on Earth, which happens to be this. So this is like the acceleration due to gravity on Earth. So I'll put a little E there so we know. So let's dive right in. Vladimir has a mass of 96 kilograms. So we know that the mass equals 96 kilograms. What is Vlad's weight in newtons? So we're looking for the force due to gravity on the moon of Vlad, where the acceleration due to gravity is 1.6 that of Earth. So acceleration due to gravity equals, it's not supposed to be 1.6, it's 1.6 is actually better. If your exemplar hasn't been changed to that, please make that change. So how are we going to do this? We're going to take the acceleration due to gravity on Earth, which we know is 9.81, and we're going to divide it by 6. And when we do that, we end up with 1.64 meters per second squared down. The formula that we're going to use is our old friend, the FMA formula. So we're looking for force. The mass is 96, and now the acceleration we figured out is 1.64 meters per second squared down. When you multiply those together, you end up with 157.44, and the unit on force is newtons, and because force is a vector, we got to throw a direction on it, and weight is always in the downward direction. Okay. Next one, this is for locations with multiple times the gravity on Earth. So a case of string cheese has a mass of 10.5, so mass equals 10.5 kilograms. What's the weight of the case on Neptune? So we're looking for the force due to gravity on Neptune, where the acceleration due to gravity is 1.4 times that of Earth. So we know what Earth's gravity is. We're going to multiply that by 1.4. And when we do that, we get 13.734 meters per second squared down. It only had 3 places, so I kept them all in there, and I'm going to round when I get to the end of this whole process. So force equals mass times the acceleration. So we have force equals 10.5 times 13.734. When you multiply that out, you end up with 144.207, with 2 rounding at the second non-zero number after the decimal point. And the unit for force is newtons, and because it's a weight, the direction is down. There we go. Well, thanks for joining me. Have a great day.